Great. Hello, Charles. How you doing?
Hi, Nick. Yeah, good, thank you.
It's really good. We're on time. I just give it one or two more moments for other people to join, and then we'll crack on. Okay, let's get going. Hello, everybody. Thank you very much for joining our webinar today. My name is Nick Law, and I'll be introducing the topic and handing over to Charles Scott from Scott Marine shortly. So this webinar is one of a series where we're presenting on different aspects and challenges of offshore wind farm construction. And today we are looking at simulating and optimizing cable installation strategies. Thanks, Charles. In particularly challenging marine environments using the software Forecast Marine. So just see if I can control this. I need to turn the pointer off.
Okay, I'll do that.
Yeah, thank you. So our wind farm today is a hypothetical case we've called the West of Clare, located off the northwest coast of Ireland. So why have we picked this topic today? Well, there's a growing importance for consideration of weather with wind farm construction. As we move these developments further offshore into more exposed areas, into more difficult conditions, and on top of all of that, rising costs, the consideration of the impact of weather during construction in more detail and at an earlier stage is ever more important. Before we go on to the main bit, I'll just briefly introduce our two companies. I'm with JBA Consulting. We're a UK expert in weather and climate risk management. And in offshore wind, amongst other things, we use our software Forecast Marine for simulating and optimizing projects, whereby we can model CapEx and OpEx, downtime, and carbon emissions, amongst other things. And we work very closely with our friends at Scott Marine, who are engineers, naval architects and operational specialists who provide expertise and engineering services to renewable energy projects. And they have a particular expertise in cable installation, hence our teaming up today for this little project. So to create the content for this webinar, we've been collaborating on the software Forecast Marine, where we've built our hypothetical project, and you can see a little snapshot of the location of the wind farm up here on the northwest coast and the routing that we'll be using in our simulations. And Charles Scott has taken the outputs from those simulations, analysed them for us today, and will be applying his expertise to answer some critical questions about these strategies. And also today with us behind the scenes, we have our senior Met Ocean consultant, Laurie Wilkinson, who's here to answer any questions. So please do feel free to question us directly on the messaging, and Laurie will get back to you as we go through the webinar. So at that point, Charles, I'll hand over to you for the main part.
Lovely. Thank you very much, Nick. And yes, my name is Charles Scott, and I'm the Managing Director and Naval Architect at Scott Marine Consultants. And I'm going to just give you a run through now of this hypothetical case, the West of Clare wind farm. So in this case, we have got an offshore wind farm, which is to the west of Clare Island, and we'd want to look at two cable routes. So we've got our single OSP located to the west of Actil Island, and we want to look at our first shore landing location, which is located at Dua, and this is a 35-kilometre export cable route. But also, as an option, we also want to look at the longer cable route in Devlin. So To do this, we also want to compare two installation contractors. So we've got vessel contractor A, which has a nominal value of the vessel has a nominal value of $200,000 per day. But then we've also got vessel B, which is a slightly more expensive vessel with $240,000 a day, but has a higher capacity and higher weather limits to the tune of about 20%. So that's a little introduction to the case. Now, why do we want to do this sort of study, and how might we use this in reality? Well, in this case, we've come up with our hypothetical client, which is the West of Clare wind farm. And we can see here the project team carefully developing their new West of Clare wind farm. And the West of Clare wind farm project wants to know the following. For the shore landing, considering transport installation, what's the cost associated with the two shore landing options? Which vessel would present the best value for money out of A and B? Considering the installation method, how might the project want to actually install the cables? And a very topical question that we're seeing at the moment is, how long is it going to take us to conduct the installation operations, and when is the optimal start period? And this is something we see being asked quite a lot in the current market, with the vessel market becoming very tight. So in summary, what's going to be the most advantageous, best value and lowest risk option for the wind farm developer? So how are we going to do this? Well, we're going to look at some variables. In this case, we've developed three main cases. So our first point to note here is that we're initially going to look at a single export cable, and we're going to look at the two shore landing locations. We've got the shore landing with the shorter route at Dua, which is 35 kilometers, and the longer cable route at Devlin. And the cables are going to be considered as single lengths, so we haven't got any jointing. And what we can see here is that, as expected, the shorter cable has a lower weight, and the longer cable from Devlin has a greater weight. And as a result, this means that vessel A doesn't have the capacity to be able to install the longer export cable at the Devlin shore landing all the way to the OSP in a single length. Therefore, we haven't considered vessel A at Devlin at the current time. And a little bit more about the vessels. Well, got vessel A, which we're calling our sort of base case vessel. And then we've got vessel B, which is our more capable vessel. So vessel A, it has a lower capacity and lower limits compared to vessel B. Vessel B has 20% higher installation limits and capacity. But the two vessels, they've got exactly the same installation speeds. And it's also worth noting that for these cases, we have really simplified it for the purpose of this webinar. In reality, there will be a lot of parameters we would look at, and different amounts of engineering that we could conduct to give us more confidence behind the limits we're using. But for the purposes here, we've just used 20% increased cost for vessel B and 20% increased limits. So for the shore landing considerations, I've just shown up on the top right here, we've got the first option of the export cable route at Dua, and then we've also got our longer route here to the south at Devlin. So what are our sort of shore landing considerations? Well, we know that Dua is closer, but is it cheaper? And there are quite often other factors at play that might determine your shore landing route and what might be your preferred one. And these include grid connection and transmission. So you may have noticed that the Dua shore landing location actually went on to another island. So this might make your onshore cable routing more challenging and more expensive. UXO risks, consenting and environmental restrictions can play a big part in your route selection. The Met Ocean conditions, which we'll talk quite a lot about in this, and the ground conditions as well. So this is just an example of some of the considerations that have to be taken into account when looking at your shore landing route. But for the purpose of this, we're going to look at the sort of marine modelling and looking at those Met Ocean conditions. And the purpose of this is to understand the cost of the different strategies that we're considering. So for our shore landing analysis, we are just going to consider vessel B at Dua and Devlin. And the reason we've selected this is that we want to do an apples for apples comparison between the shorter cable route and the longer cable route, so we can understand the cost using the same vessels. So in this case, vessel B is the only vessel that can install the longer cable route in a single length. So I'm going to present here the output from the 4 coast models that we used, and we're going to look at the duration and the cost. And just for clarity, in terms of the modeling that we've done, we have built a model that steps through all the operational steps that would be expected with installing a cable, from cable loadout, transport, pull in at the shore landing location, laying, and then pull into the OSP. And we've broken down all the steps and assigned weather limits to that. And we can see here, this is one of the many results that we get out here. And I think this is quite useful for purpose of comparison. So on this graph on the left-hand side, we can see our duration, which is by days, shows the number of days, and also the start month. And we've got the different colored bars represent the different shore landing locations. So in this case, in orange, we've got the Dua, the shorter cable route, and in blue, we've got the Devlin route, which is the longer route. And we can see here these error bars that present the P10 and P90, and the actual colored bars themselves represent the P50. So what can we see from this? Well, we can see that Dua is, as you'd expect, it's a shorter cable route. It's going to be faster and therefore cheaper if we just look at vessel costs. But we can also see that the operations are highly sensitive to the start date. So we can see that, for example, in July, we are having a much shorter duration compared to a start date in October. So we would want to quantify, how does this impact our route selection? So in this case, I'm just going to look at the P50, and we can see that in July, it's going to be the cheapest time to actually install your cable, because it's going to be the best weather. So that's your shortest duration. And what we can see is that the cost for the cable installation from Dua is 5.8 million, and the cost for the export cable installation from Devlin is 8.6 million, and that gives us a cost differential of about $2.8 million. So that's showing that the Dua cable would, in our P50 case, cost 2.8 million less than the Devlin. And in August, we can see that that cost actually, at least for vessel B, really starts to go up. So we can see that in August, to install from Devlin, that the actual cost in starting in August doubles compared to July. But we are still seeing that vessel B is a lot cheaper. And actually, if we were to start in August, we can see that the cost differential there is 13 to install from Devlin is going to cost you $13.1 million more. So that gives us a good idea as to how much difference it's going to cost us to install the 2 shore landing locations with the same vessel. But we've got two vessels, and we wanted to understand what's the difference between the two vessels. So based on the two different vessels that are being considered, which one would present the best value for money? And this is quite a common question that's also asked at the point of ITT and tender evaluation of different contractors. So this is a very useful analysis to be conducted. So in this case, we're going to consider vessel A and B, but we're only going to consider that northern cable export again. So we're just doing a comparison between the two vessels with everything else being the same parameters. But let's remind ourselves that vessel B has a 20% higher performance weather limits, but it also has a 20% higher day rate. So we want to know, does that higher performance justify the higher day rate? So we've modeled it the same way as the previous cases as well, and we can see our results here, and we can see that generally there's a very similar trend with our start date, and we can see on the left hand side that in general vessel B is faster than vessel A, which is suggests that that's down to less weather downtime. But if we look at this graph on the right-hand side, we can see generally that the overall campaign cost for that single cable installation is actually still more expensive for vessel B. So we're not really seeing a huge justification for that 20% extra cost for those higher weather limits. But let's have a look at this from a tabulated perspective, and we can see if we just look at our P50 for now, we can see that our cost for DUA is starting in June is 6.5 million compared to 7.1 million for vessel B. Starting in July, it's still cheaper overall with the compared to vessel B. But if we were to start in August, we can see that actually this flips, and what we start to see is that if we were to start in August, that vessel B actually becomes more expensive than vessel A. And it's also worth noting that you've got a higher risk of weather downtime if we start in August. And I've talked earlier about these error bars. We can see our P10 and our P90 here, and for vessel A, that risk is very high for additional weather downtime. And we can see that tabulated here. So we've added this risk value, which is our difference between our P50 and P90. And we can see that starting in August for vessel A is that our P90 is showing 163 day longer installation duration compared to the P50. If we compare this for vessel B, just here, we can see that actually that risk is still high, but that drops down to an additional 72.4 days, which is an extra 17.4 million above your P50. So what we can see here is that the vessel choice, that generally speaking, vessel A is the best vessel in the starting in June and July, but not in August. But across the board, the risk of weather downtime really increases if we would start our operations in August. And we also want to look at our installation method. So we mentioned earlier that vessel A could not install a single export cable from Devlin, and in one single length, and only vessel B could do this. So how might we want to consider this? Well, because vessel A is limited to a shorter cable, we might need to look at employing an inline joint. So for those not familiar with sort of the process of using an inline joint, effectively you lay your first half of your cable from your shore landing location. You then return to, well, you cut and seal your cable, you lay it on the seabed, you return to port, load out your second half of cable, return to site, you pick up your cable end that you've wet stored. You do a jointing operation on the back deck, which might take up to sort of 7 days, and then you continue laying away as if it was one single cable. And this is image here is a little example of how what a offshore joint might look like. And I suppose the key consideration here is that effectively what you're doing when you're doing your inline joint is that you need to have the weather limits to be able to do your joint and then continue and finish your operation. So how does that look like in this exposed location at the West of Clare wind farm? Well, the results were not desperately positive. We can see that our campaign duration ended up being 2,000 days, which is just unrealistic. And this graph on the right-hand side shows you what was the total downtime. And we can see that actually of that total campaign duration across the board, regardless of start year, you had most of your campaign duration was weather downtime. And this gives a duration of over 5 years. And let's be perfectly honest, for a single cable, that is just not going to be realistic. And based on the way the parameters that we've used to model this, we can see that this is not a feasible option. So we would probably suggest to a wind farm developer in this case that they might want to consider other options. And we could model other options such as an omega joint to break up the operations. So going on to the installation timeframes, we wanted to know how long is it going to take us to conduct the installation operations and when is the optimal start period. And we would want to know, identify to do this, the low and the high risk installation seasons. So using the 3 cases with our single cable, we can see here the campaign durations. And in orange, we can see our vessel A from Dua, blue, vessel B using the shorter cable route from Dua, and then vessel B with the longer cable route from Devlin. And we can see here that the 3 scenarios plotted next to each other, and we're just going to look at campaign duration. We can see a trend here that for all cases, starting in July gives us the shortest installation duration. So but what we can also see is that if we start going into August, our risk of significant weather delay really increases. And we can see that with these error bars here. And particularly for our longer cable route from Devlin with vessel B, our P90 duration is extremely high. And this is something that is very important for a wind farm developer to, or an installation contractor to be aware of, because if they wanted to start in July and they had any unforeseen delays pushed into August, then this could have quite significant detrimental impacts. So they might want to build that into their planning. So we can see here that starting the operations later than your optimal start date has almost an exponential increase in our duration and likely our transport installation costs. But it's worth noting that all this is for a single cable. But we mentioned earlier that our cable route has 3 circuits, and therefore there are 3 export cables that need to be installed. So we wanted to know, well, could they all be installed in one season? We don't know if they have to be, but it's always worth noting because that might save you some money on mobilization costs. And so to do this, I'm just going to introduce here our fictional export cable manufacturer and loadout port, which is Cork Cables. And we can see on this red route here, this is the transport route that the installation vessel would take to site. And effectively, we've built a model which installs 3 cables in succession, starting off with the loadout, transport, install the cable, final pull-in of the first cable, and then the vessel will return to port and start that process again. And the model will run until all 3 cables have been successfully installed. So I think the important thing here is that, again, for the purpose of comparison, we have just modelled, in this case, the shorter cable route using our base case vessel, which is vessel A. And if we compare the results for our campaign duration, for our single cable installation, we had a start date in July showing the optimal campaign duration. But we can see that when we move to installing 3 cables, that optimal start date actually moves earlier, and this does make sense because you don't want to end up installing your last cable in the winter months, which will cause significant weather downtime. However, what we can also see is that when we look at in June in particular, that our P50 duration, which is likely from a T&I perspective to be the cheapest one from the P50, also gives us incredibly high P90 duration. So effectively, we could see that as installing our 3 cables in succession in June would be our P50, our cheapest option, but also a highly risky strategy. And in this case, a wind farm developer might want to look at starting the installation in April, because our risk of our P90 is much smaller compared to our P50. Yes, it's more expensive, but it's the less risky option. And then starting in May is it's a slightly cheaper option from our P50, but a slightly higher risk. But June, we see that really increase. And then in July, our P50 really shoots up for our campaign duration. So we can see that here, that our risk, the difference between our P50 and P90 in June is 236 days, which is really quite significant. I think it's always very important whenever we do this sort of analysis that we do an interrogation into the results. It's very important that we understand fully what's going on in these analyses. We want to make sure that they're running correctly, and also that we're drawing the right conclusions from this analysis. So I'm just going to very quickly show a little example of some of the results interrogation that we would typically do on such an analysis. And we want to do a comparison between installation between the two vessels, and we could see in our results that the P90 project cost showed a large increase compared to the P50 in August, particularly for vessel A. And we really wanted to understand our results because when you're presenting this to a client or anything, or even an installation contractor, you really want to understand the risks so you can populate your risk register. And we can see an example here of the area we want to look at. And we wanted to understand why for vessel A, our P90 was so much higher than our P90 for vessel B, which was not a trend we saw in all the other start months. And we found that in 2005, there was an anomalous year, which impacted the vessel A the most. And I haven't mentioned it already, but when we run this analysis, we're using about 40 years worth of hindcast data, running multiple simulations through, and we start at various different start points. And for all those simulations, we collate all the downtime to present our P50 and P90 values. But what we found here was when we looked into the year-by-year simulations that were conducted in 2005 for vessel A, we could see that our installation duration was a lot higher, and that's shown here with this red arrow. We're up at the sort of 230 days, but for vessel B, it was a lot lower for the same year. So this is running all the same weather, and the only difference here would have been the weather limits for that vessel. And so we can see here that there's one anomalous year where we're really seeing the difference in those durations. And if we run through a step by step, you won't be able to read all this, but these are all our different operational steps on the left-hand side, and this is our timeline. So for vessel B, we can see that we make pretty good progress, few areas of weather delay, but then this is our final pull-in up here. But for vessel B, we have a similar trend. However, when we come up to this operation here, this is our duration for our cable pull into the OSP. So effectively, the vessel didn't have the weather limits, which were slightly lower for the cable pulling, and it started trying to do this operation in September 2005, but there was no actual weather window to be able to conduct that operation until March 2006, and that's what caused our analysis to really take a lot longer. And as a result of this, we can then sort of see, well, okay, in this situation, we are really seeing that benefit of the slightly higher performance for vessel B compared to vessel A. And this explains why we're seeing in our P90 case for that start month a much higher campaign duration. So that's a very fast run through of all the analysis we've done. We would come up with some conclusions to this. So I just want to revisit our initial questions very quickly. So the costs associated with the 2 shore landing operations. Well, Dua, we saw that one is the cheapest shore landing, and we saw that with a June start, that T&I, that vessel cost, was only a $2.4 million saving in June. But if we started in August for the Devlin cable, it doubled, and that cost saving is quite an important one. The $2.4 million saving for Dua, does that cost saving justify all the other considerations? And for which vessel presents the best value for money? Well, we can see that generally vessel B is faster, but it's not always cheaper. And vessel A is generally cheaper for the June and July start dates. Moving into August, it was more expensive, but we then started to see much higher risks for vessel A. And we've also covered that an inline joint not feasible, and we would need to look at other options if jointing was required, and the weather downtime was just not practical. Therefore, we can conclude that based on the models that we've done, only vessel B would be suitable for installing the cable from Devlin. And we would want to, we'd recommend that we look at other methods, other vessels, potentially using an omega joint over an inline joint for vessel A, to see if we might be able to find some improvements on that. And the other critical question was, how long will it take us to conduct the installation operations? We've shown that that is quite highly sensitive to start month duration, both from a sort of P50 value, but also our P90 values as well. We've also shown that if required, we could install all 3 cables in a single season. But again, we'd need to look at that very closely from a risk perspective. So that's everything from me. Thank you very much for your time, and I will pass over back to Nick.
Thanks, Charles. Just we're actually just a minute or 2 over, but for those that have a couple of minutes to spare, one closing thought. We've talked about lots of different strategies and elements to this hypothetical project. Is it possible, in your experience, to pick like a single strategy from all of this, or is that am I oversimplifying things?
Well, I think in my experience working with wind farms, that obviously there's a lot of considerations. The transport and installation is just one of those many considerations, and quite often you will want to understand what the cost and the risk perspective looks like, and you'll want to populate your cost book to include everything from the offshore installation to the onshore cable routes, purchasing land and everything like that. So I don't think, from a project perspective, you would be able to say straight away, yes, this is overall the best strategy. However, what we've been able to do is provide cost for all those different options to allow a wind farm developer to make that decision. And if I was to look at it purely from a transport and installation perspective, then I would probably look at either installing all 3 cables in 1 year with a start date in around the May time from Dua. But as I say, that's my thoughts, but it would fall into a much wider consideration, and it's it just shows, though, that the importance that the T&I side has on everything else that happens within that project, and your phasing of your projects. So yeah, I think Dua, from my perspective, from an offshore perspective, would be the preferred shore landing location for sure, and likely vessel A to do that.
Fantastic. Thank you very much. Okay, brilliant. So we'll call this to a close. Thank you very much for coming along. And our details here, if you do want to reach out and ask any questions on what you've heard or anything else, then please do. Otherwise, thank you very much, and hope to see you again.
Cheers. Thank you.